Jim. Welcome to another CCOM seminar. Today's seminar speaker is Tom Reis, from the president and founder of Substructure Incorporated. Some of you went out on his ship earlier in the week during their open house. Tom is a UNH alum, getting his undergrad here in business, and then he studied civil engineering at UDEL, or some of you know it as CCOM-South. Tom has over 20 years experience in the field, and he has a blasting license, and he's a certified commercial diver, and he's a U.S. Merchant Marine officer. Lots of experience. And he travels extensively with work. He's been to Iceland, where he's helped set up a sea urchin fishery, and South America, where he's done archeological shipwreck recovery. And he's going to talk to us today a little bit about Substructure and setting up ORION, their custom-built survey ship.
Thank you. Many of you I know, many I don't still, but it was a pleasure having those that did attend out on the boat this week. Fantastic. Some of you actually saw some of this slide presentation, so I hope not to bore you. We built the ORION specifically to do this high-resolution survey work. Tugboat down in Boston. This is 4 passes over top, almost no cleaning to it whatsoever. We've been able to attain some incredibly high-resolution. Shallow water work is primarily what we do, and we're hanging our hat now on the high-resolution engineering surveys. Our base of operations is Portsmouth, New Hampshire. It's an incredibly small shop for the work that we actually put out. In fact, so small that we can't fit the boat in there. We call it our world headquarters, although we unfortunately have gear all over the place. We've got a yard down in Delaware that we keep some of our equipment. My brother has 4 acres up in Elliott, and we have all kinds of gear on. Several other friends have places, storage units, things like that. It's a very equipment-intensive business that we run, particularly with the commercial diving and marine construction work. Some really quick stats. I started the company in 1996. We're located in Portsmouth. It's privately held. So far to date, Substructure has worked in 11 different countries, plus the U.S. Primarily our work is in the U.S. and on the East Coast specifically. We've worked on 26 historic shipwrecks to date, a few in the United States, but most of them overseas. We have 1 patent currently, and we have hundreds of proprietary designs that we've learned are better to keep proprietary than patent, because it gives the ideas away. And then probably our crowning achievement so far, an integration of all the different types of engineering work that we do is ORION. Our foundation is in marine operations, commercial diving. We do demolition work, pile driving, tons and tons of pile driving. That's actually me running the crane down there in New York City prior to 9/11. The World Trade Centers are still in there. We were dredging Buttermilk Channel at the time. One of the things that we do a lot is commercial diving work. This is me earlier this year working on the intake structure of a drinking water facility in Lowell, Massachusetts. We've done some incredibly high-spec, high-class wells underwater for the U.S. Navy, for other commercial interests. We've traveled to 11 different bases to date: Guantanamo Bay, Kwajalein, Royal Weapons Facility, all in the effort of doing diving work. This is stainless steel welding, 304 base metal with a 312 rod. We actually did the welding procedure at the same time and videotaped the entire operation for the engineering firm so that we could actually do our procedural welds at the same time we were doing our quals. Doing everything your mother told you not to do. It's actually not as tough as you think. Once you get used to diving underwater, and if you're actually a pretty proficient welder, the two actually flow together pretty well once you understand the techniques for doing it. This was in relatively shallow water, about 30 feet for the drinking water intake. We were running helmet cams, and we were running, there's actually one of the finished welds right there. It looks almost as good as a gray weld on the surface. And just clean it up for the next pass. The unique stuff about underwater welding is that the pass that you just laid down, because it's quenched so quickly, brittles. So the secondary passes that you put over top actually anneal the pass that you just put down, so it actually softens them up and makes them much stronger. And in today's web world, you've got enough information to go out and do it yourself.
Information's one thing.
Doesn't it look easy? If it wasn't for these operations, we couldn't afford ORION, I can tell you that right now. That's it. Along with that, we build almost all of our own life support systems. Compressors, hot water generators for our diving. Almost all of our work around here is in cold water, so we actually have hot water suits that we use all the time. So we design and build all of this equipment, including the trailers. All of the life support system is designed and built by our people at our shop, and we take it into the field around the world. The other thing that helps pays the bills and pays the bills well is our commercial diving. We specialize in projects where diving is required on them because we've got a great engineering experience with doing the work underwater. This particular project, as you're driving up and down the river, is the Irving Terminal. We drove a new sheet pile there. And it was a very complex problem because we couldn't close the loop on the back of this structure, and the sheet pile right here wasn't actually combined. So the stresses of the concrete pour we had to overcome by putting a rebar cage around there and using the cure strength of the previously placed concrete to keep it from ripping away from the bulkhead. It's a great project we did last year. We use some pretty specialized tools as well. We've developed this underwater. It's a saw that's used on the surface, but then we've actually modified it so that you can use underwater. It's a diamond wire saw for surgical demolition work. This is the project up on the Piscataqua as well. My nephew once said, "What does a T-Rex like to eat?" And it's pretty much anything at once. And this is one of those tools that, when you want to cut, use this tool and cut pretty much anything you want. But that's one of 1,000 different tools that we have for doing this type of work. We're expert fabricators. This is a winch that we recently built for the Army Corps of Engineers. We had kind of a crappy one on our boat, and they loved it so much they went through the design process and actually made a really good one for doing CTD deployments for them. We're pretty proficient in stainless steel, aluminum, regular carbon steels, as well as high alloys. The other things we do is pays the bills really well is epoxy encapsulation. We're probably one of the best companies in the world at doing this work, and a lot of it has to do with the way we develop surface preparation equipment as well as epoxy encapsulation equipment. This is a high pressure system that's used up to 40,000 psi to clean the surfaces of structures. We've got 12 different cleaning arrangements currently for different applications, both for flat surfaces and for round H-pile surfaces.
What is pile encapsulation?
Pile encapsulation is right here, what you see. So these are H-pile jackets that we previously did, and the reason that we developed this particular system is exactly what you see on the piles here, which is oil from the Athos spill. We had to develop a better system than what we were using prior to get all the oil residue off. The encapsulation process is putting a jacket, cleaning the surface, putting a fiberglass jacket around the surface, sealing the bottom of it, and then normally there's a 1/2 inch to a 1 inch annular space, and you inject epoxy into that space. It's an aggregate modified epoxy. In fact, here's some of it. It comes in buckets. Actually the one patent that we have is the pumping systems, but as with everybody, anybody who knows anything about coating, preparation is absolutely imperative to this. So coming up with a bright white surface on steel is imperative. Getting the chlorides out of the surface, we do that through several techniques of chloride resistant materials that are poured down the jacket. They're sealed completely, injected with fresh water, and then they're pumped with the epoxy, and it pushes the water out the top, and you end up with an incredible bond. And that encapsulation right there should last about 40 years.
So you start at the bottom and you seal it?
It all depends on the particular application. For deeper piles, we normally incorporate a cathodic protection system once you get down below the oxygenated area. So you'll go -5 or 8 below low water. So that gets you out of the highly oxygenated area. We're going to have oxidation, corrosion, rust, and then we'll go right well above the intertidal zone and end up with some pretty nice. I've got a picture here. This is the patented products that we developed. First generation, second generation, and then third generation pump. The third generation pump is the actual one that we patented. It's an incredibly difficult process pumping an aggregate modified epoxy mixture. So it's a plural component pump. There's a hopper for an A, hopper for a B, mix aggregate, which the worker's doing right there into it. So you're pumping gritty honey down a line at 1,500 psi, and it's incredibly difficult to do that and maintain a perfect 1-to-1 ratio. And we've developed the pump to do that, and that's really what we patented. And then also an adaptive static mixer element unit in there that allows us to eject the two streams together and get a perfect 1-to-1 mixed ratio, as well as we blend it 3 million times by the time it gets out there.
Is the water in that space before you inject it, or is?
The water is in the space in between the jackets. And this is a completed project right here. This is one of about a small section of about 500 piles that we did on the Delaware River. Those were covered with oil, and that's the finished product. We also do cathodic protection systems, and most of the time in conjunction with encapsulation work. It's a complete system that'll probably add 100 years life if it's well maintained to any port facility that uses steel in the water. We design, build, and install compressed current as well as sacrificial anode systems based on the needs of the customer. These are the people that make it happen, and I can't stress highly enough of I hold all these individuals in incredibly high regard for their talents and work. Dave Blanton, who Simon knows pretty well, incredibly adept IT director for us. He got his start doing board level failure analysis for 2 military contractors. Went over to the Ukraine to build security systems for nuclear power plants over there. Came back and was IT director for 2 major corporations locally. Took a massive pay cut to come work for us, and I thank him almost every day for showing up. He's the person that's one of the most integral people in actually the integration of all the systems that we have. He works with our video systems, our sonar systems. He works with the communication stuff that we have to have for other operations. Tom Waddington, ex-NOAA Corps officer, ex-Army Corps Survey Chief, worked for SAIC for about 8 years. He's the heart and soul of our hydrographic stuff. He keeps us on the straight and narrow, making sure the work that we're doing is up to snuff. He also kicks in where necessary. This is a power plant outage. We're doing 24-hour operations, and he's got no slack in there. Our lead diver right now, Dan Keller, on the left there, and every once in a while, I don't know if you guys know Bill Jenkins. He's an Army Corps surveyor out of the Philly group. He's up there too, helping out with another power plant outage. We're loading the stop logs in to dewater the plant right there. Andy Kelly, up on the right-hand side there, is our beloved engineer who does the last design, including Orion, goes through his hands in one way or another. Fantastic guy. Villanova graduate, mechanical engineering. Worked for a boat builder for a while before he came to work for us, and he's been with us for almost 10 years now. That's our chief counsel, my brother Jim Reis. Went to commercial dive school when I was an instructor at one of the certified schools in the country here. He and I worked together. He got his start doing work on nuclear power plants, then went to law school. Worked with me again for several years. He's back to law right now, but he still gives us constant advice, which unfortunately this world has come into need. And that's me, I'm the boss. Every once in a while I gotta get it. This is actually work on another power plant. The outages pay really well, but they're intensive work when they happen. It's round the clock work. You normally don't sleep for a week or 2 at a time while they're going on, and they're scheduled very carefully to make sure that the power's not off the grid for too long, and every minute counts. So we bring some incredibly large crews down, some really good crackerjack guys that I know. I do my shifts in there as well. These are the people. Dave is also an amazing grill master. If you ever get invited to any one of our cookouts, I would not pass up the offer. So I go along, and when I first started doing this stuff, I worked on a lot of historic shipwrecks using some of the most incredibly poor equipment in the most incredibly poor ways, and I got sick and tired of doing that, and I wanted to one, learn how to get good data, and 2, be able to present it well. So the first definition I came up with, and literally put this into my head: what is good data? And then what does it really take to get good data? I started out by going to the course here offered by Larry. Norfolk in 2000, I think, is when I went, or 2001, and got an incredible foundation for what it actually takes to get good data. This is stuff that you guys will see through your entire career, but the stuff that I ended up focusing on was the stuff that was related to the vessel. I mean, the equipment, I got the best equipment I could get at the time and built the whole vessel around a singular set of equipment that hopefully could be adapted in the future. A POS MV, an 8125, the other ancillary sensors, and then I worked within the parameters of those specific systems to build a vessel. And I looked at what other people were doing, and you know, this is, Tom Waddington gave me this recently, and he's like, hey, you gotta check this out. And he's like, you know, you basically putting a CTD or C3D at the bottom of a really narrow pole, and what you get is areas that you can see from space. And that's just done recently too, at a cost of goodness knows how many millions of dollars. And you know, there's like a 5-meter bust in that stuff, and I'm like, there's got to be something better. So we did. We went through the process of designing our own vessel, and I called 1,000 different boat builders and said, hey, this is what I want. Everyone thought I was smoking crack, and they said, we'll give you this, but we're not going to give you what you really want. Went to 3 separate custom boat builders. This one ended up coming from Raleigh, Massachusetts. They walked through 2 contracts on the work. We ended up taking the boat away from them, not as a finished boat like we were supposed to get. The quality wasn't where we wanted, but the guys that actually put the hull together did a fantastic job. Our process started with a hull twisting analysis and weight calculations. The most important thing you take away from this is we knew that we were going to run our vessel at about 6 to 7 knots. We set the parameters with the equipment that we were using. We knew that we were going to be working in 1 to 3 foot seas, so the hull twisting analysis was done for those conditions, and we left it up to the naval architect to find out where was our tenderest spot and what we were going to look for. What ended up happening is we ended up with changing and modifying the hull with different rib spacing and hull plate thicknesses in order to get our offsets from the front rib to the back rib at 1/100th of an inch and a 3-foot swell. It's an incredibly stiff hull. From there, we went through the weight calculations to get the vessel to travel through the water well. And from the analysis that we did there with specific systems, and we had to pick all the systems that we were looking for, everything that we were trying to do was to keep vibration and noise out of the hull and out of the water, so we wouldn't have any sympathetic problems with the sonar. And then we went to the build process. Pretty standard aluminum hull. There's quite a few unique fixtures in it, but it's just a basic aluminum hull that was built a little bit stiffer and a little bit better. We got it in the middle of winter. It was supposed to be delivered in the middle of summer. They were about 8 months late on the delivery of it. Took it in, started fitting it out, and it was miserable. I mean, it's cold, it's tough to put all the extra parts and pieces of weld aluminum. You got to preheat it and get it up to temp so the welds are decent and everything else, so it's just miserable. So, a year later, we just jacked the thing up, stuffed it into the shop, because that's the only place we had to work on it. And that's where it sat for about a year while we did the finish out work on it. Every single component was catted into the structure. We dry fit every single component, soft mounted everything, and then we went through the process of noise suppression. Soft mounting for every single component in here, from each hydraulic fuel line, the compressor on that side. The batteries had mounting brackets underneath them to soften it. You can even see there's rubber underneath every single bolt connection underneath there, nylon washers, a lot of stuff to prevent corrosion in the hull as well. All the electrical systems were completely sealed. Every connection was crimp soldered and shrink tube to keep any type of moisture out, but also to keep voltage leak out as well. It's an aluminum hull and corrosion's a problem, but electromagnetic interference was a huge issue that we wanted to make sure that we avoided. And also, we had so many complex systems on here, we wanted to avoid any problems. So we went through the process of making the ones that we knew we could bulletproof. Overhead system was designed so that our antennas were almost directly over top of our reference unit and our sonar head, so that we kept things as close as we could to the center line of gravity. And then, of course, it was designed so it flipped over backwards so we could trailer the unit. We built the trailer for it. And this is how it kind of looks right now. A lot of complex stuff going on over there. It's also set up for commercial diving. So we have a breathing air compressor that's hydraulically driven off the main engine, volume tank. We have high pressure bottles that go up underneath the deck in the main cabin. We have electromechanical valves. There's 2 circuits that go up to the deck so we can run an A-frame and a winch at the same time. There's joystick controls that we have for that, so the sonar operator that's looking aft can actually watch that as they're working. And the hydrodynamic features of the hull were very, very critical to us. In fact, we were just out today after we were out with Jonathan, and we were doing squat calculations again. And we got sunspots, so the RTK wasn't working so well, so we kind of canceled those halfway through. But at 6 knots, which is where that's at, yes?
Do you have a ductile log or some other type of log?
We have had 3 of those in the vessel right now, and we're probably going to be purchasing one shortly. So we've been playing with them. We've got a Sontec M9 in there. We've had one of the workhorses in there. Ron Hippie from Teledyne was out, and we were playing with that actually at Energy Ocean last year. And that's high on our list, as well as upgrading to the other constellations so that we can get a much tighter resolution. And POSPAC, we played with POSPAC, that's still on our list as well. But real-time stuff, so that we know that we're getting good quality data, we still want to have RTK almost all the time. Traveling through the water, we did a lot of work so that we got rid of the rotational torque of the propulsion system. I know I spoke to someone about this at some point. But the jet drive system that we chose is a variable pitch impeller. It produces almost no cavitation at low speed. The propulsion noise is actually out the back of the vessel, so that none of the sympathetic noise that's created from the propulsion, cavitation bubbles and things of that nature, can actually have a direct line of sight through the sonar head. Dry exhaust that goes out the back of the vessel is the same thing. It's actually dry, it's out of the water, so there's no reverberations that are actually going to cause any problems. It itself is also tucked behind the transom, so there's no direct line of sight there. At running at 6 knots, she stays right through to her lines, and there's almost no lift or squat. We've had some incredible performance results from that. This is some of the stuff for you right there. We've got 2 sonar mounts that we use over the side. They're both built as hydrodynamic foils, so we get rid of some of the vortexing effects and the harmonics that you get from normal round pole mounts. We've got quite a few adapters to fit other systems. This is a 4125. That's a Knudsen chirp system there. And then because we've got such a tight reference frame with our moon pool, we're able to adapt almost instantaneously with a single adapter plate. We mill those out at a 1/4 inch thick and fit it for any other type MRU, and we can IMU, and we can plug and play instantaneously.
So these are over the side?
Those are over the side, correct. And there's a workhorse right there on the side. And then some other components we use. It's portable. I like the one Port Jeff Ferry. We had a boat on a boat there. That was good. Marathon, Ontario. That's probably the farthest we've taken it so far. North side, the very north side of Lake Superior last year. We've had it down in Norfolk, Virginia, causing a stink down there in Hydro 09. It's funny for some. I never knew Reis had so much power until I got down there. And this is what the vessel does. We do incredibly high resolution work. Our normal parameters are about 3-inch accuracies with work that we perform. We do a lot of quality checks to make sure that we maintain that. And for this particular application, it was the tall ships. They needed navigation help, so we went out for the Port Authority of New Hampshire and did this. This is Prescott Park. This is where the tall ships were sitting last year for the festival. They couldn't put them at the main pier. They just didn't have the space. They had some other operations going on, so we gave them that. And then this is, thank you, Lindsay, for a wonderful program. We gave the pilots a kind of bird's eye view of how they were going to be coming into the channel there. Same type of stuff. This is self work for, is he here? Track. Not here? Not here? Sure. This is survey work that we did with him last summer. It was primarily for the backscatter imagery. This imagery came out really good. This is probably one of the few data sets that we were able to cube. All the vertical work we do is too complex, and the cube would kind of throw out all the stuff that we're really, really working for. But you can see the drape bathymetry and backscatter, and then an automated system for pulling that out. This is some work we did for Rhode Island DEM, and the Jamestown Bridge, which was demolished and removed. You can see where this was supposed to be the dump site. Not a bad aim going on there, but again, it's not that tough, I don't think. I mean, it's a big area. I mean, it's really big, and they still missed it. But you can actually see the backscatter on here too. You can see how much destruction there was in the seafloor from all the misses that they had. And I think the greatest stuff for any geologist, of course, is all the scarring through the bedrock up there. When that's blown up, it's a beautiful feature there. We've been doing a lot of work with DOTs and engineers now for doing high resolution bridge surveys. And point cloud image there, this is in Richmond, Maine. We've been back there twice now to do condition surveys. This bridge is on the red list, so they want to have it done every single year. We've done 6 to date for the state of Maine. It's pretty difficult to get that data accurate. And I'll show you as soon as we turn off the webinar, I'll show you what it takes to get that stuff. Tobin Bridge down in Boston. Each one of the abutments there. And distance and close up. Some tricky navigation in and around here with all these piles. It's kind of suicide for an expensive boat, but we managed to pull that off. And this is the bridge up in Wiscasset, railroad bridge up there. These are uncharted objects on the bottom. I almost ran right up on top of those. Crazy for trusting a Noah chart. Anyway, we passed that information along, I believe. We actually thought that we were screwing up. We had navigation busts and all kinds of problems here as we were mapping, and as the tide dropped, we could actually see that all of the things that we actually saw in the sonar were very true. Because we're working around a very tight area, we can do continuous dips basically in these, so our sound velocities are very, very well taken care of. And then we have calibration runs that we'll do right before. But because of the way we set our boat up, we've never been off more than 100th or so on our calibrations. We can drop the sonar heads back in there. It's an incredibly tight alignment almost every single time. And this is the differencing between the bridges. Richmond in 2009 and 2010, and then we were there in 2009. It was an 11-foot flood stage. The currents were absolutely raging while we were there. We still managed to get a phenomenal data set. And then you can see the differences. The erosional areas are the darker blues, and the deposition areas are the lighter tannish color there. It was amazing how much seafloor was moving in a small area there. This is a boat ramp, the boat haul out down in Newport. You can actually see the propulsion scars on the bottom from the boats that are being put in and out. Marine terminal down in Boston. There's 4 cars we managed to locate for the state police. Very good friend of mine's on the dive teams down there, and yeah, you can see the wheels belly up and the point cloud down here. You never know what's going to pop up. This is a barge. We're going along while we did the Tobin Bridge. We went right along where the car terminal is there, where they bring the new cars in. And the funny thing is, the Google Earth image actually has this barge sitting right there on the surface. Lo and behold, we found it down on the bottom. You can actually tell how it sunk too. This thing came down first, plowed the sediment, and then actually drifted down into the bottom. And you can actually see the line still connected to the barge right there. This is one of our, this is one of my favorite data sets. This is down in Wilmington, Delaware, one of the customers that we have. You can see the Google Earth image, and this is really apropos, because they used to be able to bring the ships in all the way up here. The newer Google Earth image shows the ship here. Down in Delaware, there's one dredging contractor. They were stupid enough to let their permit expire for disposal on the New Jersey side. There hasn't been any real dredging work going on down there for private consumers now for about 6 or 7 years. The sedimentation is unbelievable down there because of the turbidity in the water. Every ship that goes by up the main channel, if you're looking off the fantail of the vessel, is just churning the bottom up. So there's just a constant slurry of sediment there. And you can actually see where the vessel jams up into the mud. They drive these things hard up into the mud. There's an explosion of methane gas, and it's just frothing as they put the bow up in there. So we're coming up with different engineering solutions for them. It's a complex problem. There's some very shallow water here. In fact, one of the vessels that backed out of there ripped the hull out, ripped the bottom out of the ship. They had to scrap the ship. Most of the ships that go to this terminal, it handles salt, so normally their next trip is to India where they drive them up on the beach. But that being said, it was a very new perlite ship that was actually ripped apart. These are 2 natural gas pipelines that go through, and there's some serious construction problems with putting another cellular coffer and doing dredging work in the area. You can actually see all the propulsion scars from the tugboats that are handling here. You can see that with the sunlight illumination, you can actually see all the different levels where the ships are jammed in based on how much cargo they offload. So they'll come and empty the front of holds, they'll take some off and then drive it up a little bit farther, keep driving it up until they can actually get the back of the ship, which you can see in the last picture. Hangs well out off the stern, off the last cell. They can't get to the last hold until they drive the ship up in there. So they've got a unique unloading method now. There's a sailing terminal down, right down in Boston, East Boston. I don't know if you guys have been down there, but there's a dock system right up in here, and just another beautiful tugboat sitting on the bottom there. We're doing a lot of work for power plants now. In fact, this is intake for one in Saugus, Massachusetts. We're doing a current study there starting next week with the outage that we're doing. They have traveling water screens at this facility, and EPA believes that traveling water screens are basically a fish filling machine. They believe that everything that goes into one of these systems is basically turned into fish pulp and then spit out the other side. Normandy Associates is down there right now doing a fish counting study. Needless to say, every fish that they find is dead because they end up putting it into a high rate discharge plume that pins it up against a net that they're actually sampling with, and it drowns at the end. So it's they come out alive. They should make it back to the sea alive in the pipeline here that actually is broken. You can see where the discharge ends up going across at low tide. But I'm down there doing work, shooting video, and these fish are just happy as can be. It's the highest current area, so they're just sitting there in the current, eating away. And they got these really cool things on the traveling water screen called fish baskets. And the fish baskets are there just in case the traveling water screen goes up and the fish are picked aside, and they'll catch them and then dump them out and put them back in. Well, in reality,
what's a traveling water stream?
it's a conditioning system for the cooling plant. So they go through a trash rack, a very coarse bar grating that takes out logs, big chunks of stuff, and then it goes to a traveling water stream, which is just a giant belt. In this case right here, it's 4 stories tall, goes into the water column. There's two, it's a binary intake system, so it's a redundant system, so you can shut one down if you need to and work on it. And it's just a fence, basically. It's a belt fence that rotates around, and each individual, I think I got pictures on my computer too. Each individual piece is about 4 feet wide, 2 feet tall, and there's a little basket at the bottom of it. And the fish really enjoy these baskets because they rest there, and then when they're hungry, they go up into the current, they'll eat a bit, and then they go back down in there. And my understanding now is if the baskets weren't there, the fish would be even happier because they wouldn't get caught up and shot over the side. So I'm talking to the EPA guy recently, and he says, oh, these things are terrible, they kill so many fish and everything else. Everything that we get out of these is dead. And I'm just like, oh. There's a reason for that. So we're actually doing a current study to show that the fish can actually swim against this current. We're down there, and there's fish swimming down, there's eels, there's crabs, there's everything. It's a mecca of life because it's the most oxygenated area of depth that you can imagine. So not to make it easier on the power plant, but it's just literally a matter of they're $5 million for a 2-year study for these guys to do this fish stuff, and they're killing every fish. So I'm a little concerned that the data may be a little flawed. So out of the generosity of my heart, we're going to throw in an ABCP there and take some video, and hopefully they'll change their tune a little bit, at least come up with a better system. Standard pre and post dredge stuff that we do. This is South Portland, just prior to. This is a pre-dredge survey, and then this is the post differencing right there. Pipeline work, EPA, Department of Environmental Protection, whatever the states are, require need to be inspected every year or two, depending on if they have open diffusers or ductile diffusers, some closed diffuser setup. So we do a lot of this work where we'll evaluate it, get a picture, and then we'll actually go down and shoot video. We overlay the two, so you can get a very, very good quality picture. On this one, these are actually the weights, the concrete weights on the pipeline. These are actually the diffusers in between. This one is twisted off the pipe because of the mechanism that they used to put it on there. We actually designed a new mechanism for them, so it's a breakaway diffuser, so that can't happen again. And went down and installed it for them. Standard intake to, this is Mount Sinai Harbor down in New York. This is a jetty study for the Army Corps of Engineers. Topographical overlaid on, they couldn't afford to do a laser scan, so they just went out there and did some topo shots. You get this beautiful high resolution bathymetry, and then it's kind of screwed up with, 3 shots across the jetty, so you end up with this that's what they got. So we had that storm where it blew 50 knots for like 2 or 3 days last year in between these two events, and literally the sand covered right over top. The work that we did was useless in 3 days. So, but they know what's underneath it. This is Marathon, Ontario. It's a sediment capping project. They've had a pulp and paper mill that's been belching out toxic waste for quite a long time, and this area right there is all contaminated. So they're going to be doing a shallow water capping project there with a thin layer. Sometime next year, I believe, we'll probably be back up for condition surveys halfway in between and then a final survey. And this was for object detection. We did a 4125 high resolution side scan on it, and then it draped the bathymetry. We were able to hook it into the reference frame of the vessel pretty tightly, and we overlaid the two. It was georeferenced very, very well, so we could actually get the bathymetry and the side scan to show up very nicely. This is just a CAD cell down in Boston. We were driving by. We figured all of a sudden the bottom fell out underneath the boat, so we figured we'd get a nice picture of that too. But you can see the dredging scars on the bottom, right here from where they're dredging up to it, and then the beautiful deep cell there. Hydrothermal project for electrical engineering student here at UNH. We went out and got we deployed the thermistors for them, and then actually took some bathymetry measurements and some temperature measurements for them as well in other areas. And then, thanks again to Lindsay. We did some work with Mike Brissett, Hydromosaic, and this is the data set. Andy spent some time putting this together. I had a presentation for the Propeller Club of New Hampshire last night, and all the pilots were there, and they were pretty surprised about the damage that they were doing, and of course the high mounds that are in the middle of the river and all this other stuff that they're running over all the time. I don't know if you guys have mapped those. They've moved. The last time we measured those and checked them out, they were 2.5 meters tall. Now then there were 3 humps, and now there's 2 humps, and they're a little over 3 meters tall.
Where are they located?
They're located. Oops. They're located right off the Simplex Pier, just down from here. Right there, right across from Simplex. And then there's another high hump that's off of Franklin Island that's actually above the charted navigation channel. So we've dove most of the structures in the river, so it's actually kind of neat to see. These are air bubbles from the GE plant there. I promise I won't click it again. But General Electric has a peaking plant that's on the river, as well as the Schiller Station and the Newington Station.
What's that?
And that's a newer gas turbine plant. It's a 2-to-1 on the vertical.
So this big gouge up here, this thing here,
Yeah.
what is that?
Those are sand waves.
You sure it's only 2 to 1?
Yeah, I'm pretty sure it's 2-to-1. So Andy took the vertical stuff out,
But-
midpoint cloud those, and then.
A lot of the other stuff looks like sand waves, that doesn't look like sand waves.
Yeah, they are.
Really?
They are, yeah. They move quite a bit.
Is that what they call the simplex shoals?
That's it.
Where they're trying to dredge that money point?
That's all Franklin Island right there.
What's going on there?
Look at this. It's a buoy. It's River Road right there. River Road facility.
A little short.
But yeah, the pilots were amazed that their tugs were causing those depressions in the water right there too. Those are the tugs from pushing into the facility. That's actually the propulsion from the ship. Yep, digging those holes out. And yeah, this is Franklin Island right off of here, and then these are right off of Simplex. Right there.
So where's the turning basin?
Turning basin's up here in this area that they're working on.
We're looking downstream.
You're looking downstream right now. Yeah, this is Avery Lane Terminals. There's the gas tanks right there for C3.
So just got,
Yeah.
the power plant.